Okay, so this will be our last introduction to programming for visual effects. This is a very basic introduction. We have reviewed VFX programming in Houdini. This one is Python programming. So you know Python is a very it's a very popular language, and it works in multiple different environments. It's not just for Houdini. It works inside Maya, Nuke, you know, Premiere, all sorts of applications. This language works everywhere. So that's why it's a very good multi-platform way of scripting. So where you can write Python scripting. So if you look at, if you open Houdini, and instead of like a, so you know that the layout that we work most of the time is a build layout, where you build things. But there are other layouts that you can make use of it. So one of them is technical. When you go to the technical layout, let me just close this tree view, or it looks like an outliner. You get a Python shell here. You can type Python codes here. One of the places that you can type Python code is here. There are other places, like if you go to the window Python source editor, this is one of the places that you can write Python. If you generate a new tool here, this new tool has a script section that you can write Python code here just directly, and just that code turns into a new shelf tool. Let me delete that. Where else? You can. Oh, okay. So we've got a bunch of nodes that you can generate. So pretty much like attribute wrangle, you can tab and type. You've got this Python script node that is, you know, it just like gives you this Python shell, and you can write down Python. If you are inside a geo or sub level node, inside the geo node, over there you can type Python again, and just like you get this Python node. It's pretty much like attribute wrangle. You can write there. And last but not least, you can write Python in a stage which is a Solaris node. We'll talk about that once we get to the Solaris. So let's start with a simple. Let's do a simple start. So like a box city builder. I am going to create that city builder with a bunch of nodes, very simple, and just do the same procedure using Python. So what is the procedure that we're gonna go through? So so we're gonna create a grid, and then a box, and then like scatter this box around the grid. As simple as that. So so let's say here you see that like this one is different, like it's kind of swapped. If you don't like it that way, you can click on this and they just like swap, and then the node tree returns back to its original place. Sometimes, which is a very popular layout, is you hold Alt and click on this middle, you get like them lined up next to each other. So this is going to be parameters, which I don't like parameters to be here. I would like it to be there. Just click on this one. So I like nodes be here, parameters there. This is a nice layout. So I add a, are we in an object level? Yes. I add a geo, and I call it city builder, whatever you want to call it, or just city/builder. And then inside that, I would, or just, I like camel casing. Inside that, you can add a grid. You can, a grid. What I would do is going to be very simple. I would make a grid, I make a box. And basically what I do, I just make a fancier version of copy to points. So you can copy, you can search for copy to points. Points will come from grid, objects come from the box, and then you get box distributed around the points. However, we want to create a bit of variety. So what I do, instead of just jumping into that, let me just hold Y on keyboard and cut that. So this is our grid. I scatter some points around it. Scatter. So like you see that it gets 1,000 points. Maybe I just want, I don't know, 20 or 30. I don't see, if you don't see these points clearly, again, press D, go to the background, go to the light, dark, and make your background look darker so you can see points better. So these points are very scattered very randomly. So let me just like make more points. And then I would gonna say that there's a very interesting note which is called relax, point relax. It helps you to relax these points and their positioning. But what you won't see is that if it doesn't work, it's because you're looking for a PS scale attribute. So what I want to do, so these points doesn't do anything because we need a, so it has to relax the points based on PS scale. You see PS scale here? If in other words, each point might have a circle or area around it, so it uses that circle for that. So I add a attribute randomize node here. So I just type attribute randomize, so you get this attribute randomize. I add it here. So what attribute I want to randomize? Not color, but PS scale. And this attribute randomize PS scale, I wanted to start, so let's say each one of these buildings, some of them would be small but not zero. There's no building that is as tiny as zero. So they are like, if you consider an average city building 1 unit, so a small city building could be like half of it, and a large city building could be 2 times of it, right? So now if you relax or attribute randomize PS scale, before we get in, we're gonna relax in 3D. That's what I forgot. So if I relax in 3D, yes, so you get like, okay. So you see they are getting kind of like comfortable and relaxed based on each one of them has a scale, right? It uses that scale to relax them around each other. So then we just like do a copy to points on that one, and maybe just make the background a bit larger. So this is what I do. We do copy to points. We can do the copy to points just now. But the point is this. So these boxes, they are not, if I turn on the grid, they are inside, so they're not like standing on 0. You remember that we did a very interesting thing here. So like we use a transform node here to move them up. like we grab them with this transform node, move them up, right? But like, how much do you know that you have to move them up, that all of them land on the proper so on point 0, they all sit on the ground. So this is how you do it. Like for this translate to y, I go and grab it from center. So if I find the center of it, or size, like half the size of it. If you want to do it like without transform node, this is how you do it. Like you say that the center is equal to the half of the size. But what I would say that yeah, like this, like you get the center, copy this parameter, or you copy the size parameter and paste the relative to center and then divide it by 2. So you get like all of them landing on the floor now. But what I want to do is, because this happens within the box node, I want that to happen in the transform node, because I want you to learn how to transfer attributes relatively among different nodes. So I grab that you know, size, I copy that parameter and come to the transform, go to the transform y, paste relative, and then divide it by 2. And you see that they all land on the floor again. However, the movements is based on that. So like now if you do it this way, it's very interesting, because like now if you just like scale them up or down, like if you just change the size of the cube and things, they all should work and land on the floor. So now we have a bunch of building in different sizes. Maybe we need a floor, maybe like if I merge it here with that grid again, the result would be interesting, but that grid is not big enough to hold it. So I add a transform node in the middle of it, make it larger, and it fits the city. So this is like a kind of a city block. Let's assume that like it's a very basic city block. And if I want less building, I play around with that scatter points. If I want more, like if I want to control this randomization, I can play with these values, like minimum value, maximum value. If I want more relaxation or less, I can control it with this kind of relax P scale. So you see that I've got a very nice procedural control over this very quick and fast city builder. Okay, so let's do all of that using a Python code. So I hide this, I make another tab, and I call it okay. So what I would like to do is, because we're going to keep deleting everything that is in the OBJ, I open another, you don't need to open another Houdini. I open it because I want to show you the difference. So you're comfortable with what you do. Because I will keep deleting what's inside the OBJ level constantly. So let's keep this one here. You don't need to open. You just like, oh, it's a good time to look what's our tornado look like actually. Oh, that's not bad so far. I'm gonna play it. You see how nice it just like swirls up? Okay, I can stop that one from simulating. It's enough, but you got the idea. And actually I could, I'm gonna close it and save it. Okay, so let's get back to the technical with a bit of adjustments. Oh no, not that one. Close it. Okay, let's open window Python source editor. Here we write codes, and the moment you press apply, it just generates the codes here. So our first step is that you can start with like I just skip this part. We can like write down these lines in the shell, but I'm gonna start writing them right inside the editor. Okay, so you can start writing them here in the shell, but it's a bit cumbersome and like not too comfortable, but like it's much easier to write down here on in an editor. So we start with something interesting, which is the with this one, import. So if you start with the shell, you don't need type to import who, but everything at source editor starts with import who. So what does it mean? So Python, as I said, is a generic language, is a language that works in different applications. So side effects people, the people who created Houdini, they created a bunch of classes of codes that is driving Houdini functions using Python codes. So the moment you say import who, it means that, okay, so we're gonna work with a lot of nodes. If you don't do that, if we're gonna work with a lot of Houdini nodes, in your week 8 folder you get this who module function reference sheet as well. If you don't write import who every time that you use any function, you just have to type who dot node, which means that go look at the classes of functions within Houdini, grab node, and grab create node command. Okay. Here you just say that no, let's import Houdini once and then use it. Okay. You can, like, if you use like commands from your OS, let's say through Houdini you want to go and do the stuff in Windows, let's say find a file, load it, then you can import OS commands for your Houdini as well. So the first thing that we do, like at the moment we don't need that OS. The first thing that you can do, you can say that, so let's create the object level. So what level we are at? We are in object level, right? So our object level is basically a Houdini node that is an OBJ. This is a type of a node here. Basically, this is, in another words, so far you might have not noticed, but you are working in a master node when you say you're working in object. It's a level, it's an environment. So we just, by creating that, we get into that master node. Now let's create our city builder. So this one I can here. So in You remember in Vex you were ending with this. You don't need it in Python. And you in Vex you were using slash slash to show the notation or annotation. Here you just use a sharp. You can use a sharp or two sharps to say that. Okay, so we enter object level by this command. Then now it's gonna be, so we're gonna create a geo node called city builder or whatever you want. So how you do that? You just say that city builder that I want to generate is basically an object level of obj level, that name. That could be anything, by the way. I could say just obj or level, or I don't know, master level. That obj level dot. So we're going to create a node. But what type of node? So again, let's look at what I have provided for you. Whenever you want to create a node, you have to have a node type and a node name. So the node type that I want to create is a geo node. I put it in quotation marks because it's a string. So let me just create a geo node here for you to see. When I go to that information, you see that geometry object, and in parentheses it says geo. That's the node type. So that's what I have said here. You can name it here as well. So just type geo and then quotation mark city builder. Okay. So we generated that node. Actually, let me delete that. So when I apply that, you get that city builder. It's empty, but we have generated that node with a command. That's our first Houdini Python code. Yay. Okay, let's move on. So now you want to create a box and a grid in it, right? So let's do that pretty much the same. So I'm gonna say that I'm gonna create a box and a grid inside city builder geo node. So how we do that? So let's say a box that you want to generate is actually a city build is inside city builder. Inside city builder you create a node, but what kind of node? A box node, and we're gonna name it I don't know, block base. Close. And for the grid, I would say grid is equal to, again, inside. So it's now you're getting the rhythm of this language. So when we start with this like name, it means this is the node name. So city builder. So how we know that node name? It's been defined. It's been introduced earlier. And it happens all inside object level, which has been introduced earlier. So we just see, you see how nicely we are getting to the details. So create node, it's a grid. Let's call it, I don't know, ground, whatever. Ground. So if I apply, I get that node. Inside that, I get two nodes that are on top of each other. One of them is a block base, which is a box. Do you see that? And this one is a ground, which is a grid. Okay, so I'm going to delete that, because every time that we generate, every time that I press apply, it generates a new one on top of the other one. So next, so we generated that. I'm going to talk about this display flag. If at the moment when we generate, the display flag is always on the first generated node, which is on the box. If you want to transfer that to the other one, that's how you do it. But let's carry on, because later on we're going to set the display flag on the latest null node. Like let's look at the other. So let's assume that we finish here with a null node and call it output. So we want the display flag to be on this, not the rest, not on the box, not on the grid. So let's keep that for the later. So you see that every time that I press apply, I get a new city builder node. You don't want that. So you want, what if I want that every time I press apply, everything gets deleted and the rest would be generated? So let's say inside this object level, so let's create a for loop command. Let's say for any node in this object level, because I have introduced the object level, and anything inside object level, we call it children. How I know it? I didn't know it. I looked at here. I looked at the reference. I looked at how I can figure out whatever is inside a node, and I figured out it's children. It says useful for grabbing all the nodes within the node. I'm going to grab all the nodes within this object level node. And here you need a colon. And be careful. Contrary to VFX, Python is sensitive to tab. So you need a tab when you use for or if then else loops and stuff like that. Here you just type node.destroy. So if you don't know what is destroy, if like just a fancy name for a delete, here destroy deletes the called open node. It deletes it. So if I generate that from now on, when I press apply, and then I press apply again, you see that there's no new node generated. We keep this for a while until we are happy with our coding, then we delete that. Because at the end we want this to not delete everything inside the object level, right? So, but for the moment that we are coding, we need it. Hang on, I'm gonna save this, otherwise I am fired. So this is Python scripting. Okay, so let's move on. So that was how you generate a new node every time, how to avoid that. So let's get back to what we were doing. So we scattered some nodes, some points, and we assigned and we copied those points with those points to this box. Okay. So let's write them down here. A scatter. So I'm gonna create a scatter node and also a copy to points node. So let's say points. So we're gonna create a bunch of points, right? I just create a variable called points. And this variable called points is actually within City Builder GO node, and is going to create a new node called, so how I know that what is the name of the, so you remember that this is the type, the first one. How I know that what is the type of the scatter node? If I click here, it says this is scatter node, and the type is actually, look at the type, it's called scatter colon 2.0. We need that. So it looks weird, but like sometimes nodes name have changed through time. So we're gonna provide that too. So it's this is the type of the node that I'm gonna create. Scatter colon 2.0. That's the type of the node that's gonna create. I might call it. You can leave that calling or naming part, and then it creates with the default name. However, you can name it as well. You can call it, I don't know, box points, and then create a copy node. I call it copy, and it's a city inside a city builder dot create node. And what type of the node? It's a copy to point node. Copy to point node is, if you just middle click on that, it's called copy to points colon 2.0. So it means that this is a very interesting way of calling nodes. It shows that this node has been updated in the development of Houdini. So we call it, what type of node? It's a copy to points colon 2.0 type of node, and it's called I don't know, box copy. So if I apply that, I get, if I press L, I get a ground, I get a box, I get a copy to points, I get a scatter node, but there's no connection. Yeah, I know it's it might look weird, but that's how we humans do connect these, right? So now we're gonna tell a code to do that. So let's create connecting. So actually, I'm gonna hashtag. I want to do 2 hashtags for that one as well. I can do 1, connecting scatter node to grid. And so before connecting that, you saw me, like I got inside, everyone was, all the nodes were on top of each other, and I pressed L on keyboard. So I just add one thing at the end of here, and I call it city builder dot layout children camel case. This is basically pressing L. So I'm telling the code, like every time I work between, every time I press apply, just you do that, you press that L yourself. So let's create these connections. So how these connections would work? So let me just disconnect that. So let me just add a attribute wrangle, because it has a bunch of connections. So this is the first one, this is the next one, this is the next of the next one, this is the next of the next one. Okay, that's one way of calling your connections. Or this is 0, this is 1, 2, 3. So it starts with 0. You can say that points. So I'm gonna connect, let's say, this box points, right? I'm gonna connect this box to box points. I can say points. Set input is for connecting, and say that connected to the first input. What is the index number of the first input? 0. It looks weird, but that's how it is. 0. And what it is called, what it is supposed to be connected? Grid. There's another way of writing this. I can say points dot set first input to the box. This is, you don't need to be worried about the index number, which is 0, 1, 2, 3. You just like put it that. But you will later on see that sometimes we can't use this convenient method. So the second one was, let's say, I just wanted to, okay, so this copy points, this one has two inputs, 0 and 1, or first and next. So here how I do it. Copy points dot set first input goes to box, and copy dot set next input goes to points. Okay, let's apply. So you get this city build. Oh, there's one error, which is at line 21. You get error, just click on this, jump to the line 21. Here I have probably, so yeah, this is the error. So you see that here I have introduced the variable as point, but I have written as points. Okay. So this is your lifesaver. Just jump onto the line that it gives you the error. So let's apply. Line 23, I have a problem here. Copy set next input to points. Yes, apply. Okay, it's gone. So now when I get inside, it's already laid out. You see, it nicely laid out. It has created the connections as well. So let's move on. So we created scatter and copy to points. So let's creating all the other nodes. So what we have here, we have transform node that is connected to the box. We have attribute randomize. We have relax node. We have another transform node that is connected to grid. So we have a merge node. I'm going to create all of them, and I do create all the connections within them as well. So let's move on. So I'm going to create hashtag create a transform node for the box. You can call it whatever you like. I call it match floor is equal to city builder dot create node. Okay, so what is it? What is the type of a transform node? We have to find out. I middle click on it. It says X form is the type of this form. It's kind of like a code name for this type of node. Quotation mark X form, comma, and I call it like match floor. And then I'm going to connect that to the box, right? This is going to change the size of the box. So I call it match floor set first input box. And then I want to so if I connect that to, so then this scatter point should not be connected to the box, should be connected to this match floor. I have to reset the connection of, so let me call you reset the connection of copy node. How actually I could have avoided that if I knew my procedure from the beginning. I could start from beginning writing that, but this is just for the sake of you knowing how things happen. I can say that set first input for that copy node that we have generated early on to match floor this time. Okay, so you remember I have created two nodes for the attribute randomization, which is this PScale attribute randomization. And let's middle click on that attribute randomization. Code name is attrib randomize. So, and then I'm going to connect it to the points. So the connection is to the points. So how to write that down? We write it this way. Actually, I'm going to say that add attribute randomize and connect it to the points. Adding attribute randomize, as you have realized, you just name it the way you like. I call it a PSK randomizer or randomize, and it's inside city builder node. It's a create node command, which is going to generate an attrib randomize. I probably would have spelling issues, but it's okay. I can carry on and just like I come back and fix it as you saw earlier, and call it pscale rand and pscale rand dot set first input, which is the connection of it, and as I said, it's going to be to the points or point, because I have introduced it as point, not points. So let's see if it works. Apply it. As I know there are some issues here. So line 26, you can type 26. Match floors, create node. X form match floor city builder city build create node. I think it's right spelling. What's wrong with it? It's X from, oh sorry, it's X form, not from. That's the problem here. On line, this one is on yeah, I think that was the issue. Let's apply it again. Yeah, it's gone. It created the match floor, connected that, created the attribute randomizer, and yeah, all of them are created. So next step is creating that one that scaled the ground, connected to the ground, and point relax, and connect to the PScale. And here there's a point here that I'm going to explain to you just in a second. So create another transform node for scaling the grid or ground, if you remember, as we named it. So I call it grid scale. Grid scale is equal to city builder dot create node, and it is X form, not X from, X form, and you can call it I don't know, grid scale up, and now it's time to connect it to the So grid scale dot set first input is grid. Now adding point relax, adding point relax and its connections. So I call it relax is equal to, it happens inside city builder node, and it's create node, it's relax type. I knew the type, you can go and check it if you don't know. And point relax, and I'm going to connect it to the P scale. As you remember here, point relax is connected to this attribute randomization that randomizes P scale. So I'm gonna, so relax set first input is P scale grid, or grid P scale, grid P scale. And oh no, we're not going to connect it to itself. We're going to connect it to PScale rand, the previous node, sorry, PScale rand. And also, so this relax node, you remember, can have multiple inputs. You can grab an input from here, and it gets a better relaxation. So it doesn't go beyond that. So it kind of reaches to the edges, but it doesn't go beyond that. So which is nice. So I'm gonna do that second connection. Hang on. I'm going to tell Greg that I'm in a class. So I would go and tell that the next, so the first input was PSK rand, but the next input is set next input is the grid. Okay, so you remember that we had this copy to points. Copy to points was connecting to the scatter or transform. We're gonna reconnect it to the relax. If you look at the original note, you see that copy to points. The second input is connected to relax. We're gonna update that, but I cannot tell this time that next input, because first input gets that, but this one is, because I already have used next input. So I'm gonna say that, okay, don't confuse, I will guide you. So copy node, I'm gonna update that connection to that copy node. Set input, I will tell you exactly what input you're gonna be. When I say 1, it means the second input. Don't get confused. 0 is the first input. 1 is the second input. It's weird, but it's what it is. So that's okay. So far, let's apply. I hope there's no error. All good. So all the connections are there. Now we're gonna like kind of do the last part. So which is creating the merge node and merging them together, and then creating a null node at the end. So you remember, there's a merge node, there's a null node. We're just going to create there. And then I'm going to set all the flags. You see all the visibility flag to that last node. That's what I'm gonna do just now. I say that, okay, create a merge node and its connections. So as you know, you just name it as whatever you like. It could be merge 1, merge 2. It happens inside a node, like inside which node? City builder node. It's gonna create a node called, so this is important. So this one is not a random name out of whatever you like. It's a type name. This is a code name. So you have to middle click on the node and say that, oh, this is a merge node. So this is a null node. This is a copy to points colon 2.0 type of nodes. So this is a merge type of node. This second one could be anything you like. It could say that you can say box and grid merge. The first one is important to figure out exactly what it is. Okay, let's create the connections. Set first input to copy. Set next input. Set next input to grid scale. And I'm going to create the last node, creating the last null node. So I'm calling it output. You can call it null, whatever. I call it city builder create node null. And I call it output, or you can, if you remember, I like to add this underscore at the beginning of the null nodes, especially the end null nodes. Let's connect it. It just has one connection, which is set first input to merge. So if I create that, you see that the I flag is still on the box, is the first. I just want to say that set the flag here. You have to set two flags there. You have to set output dot set display flag. So set display flag is on output now, which is true. Output, which is output, is a variable I created. It's not a command here. This is a command. The second one, set display flag, or set render flag, but that first one is the variable we created. So these two are true. Set render flag, apply. Oh, I think you attempted set display true. Ah. Yeah. Okay, there we are. Now you see that the display flag is on the last one. Sweet. We generated all this network, with that. But the point is, the attributes are not. We didn't have a time to go and set. So here in this randomizer, for example, I should set this to PSK, but you don't see it here. Let's do them, and then that would be the end of it. So setting parameters. So setting parameters is easy in Python. It's a command or like function called parm. So let's say after this box, when I created a box here, I can tell that box parm. So how do you know that? So let's say you select your box, you middle click on, you just hover on, you don't need to middle click, hover on that size. I just want this box to be like a bit taller. Size has size X, size Y, and size Z. So that's how I know that this is the parameter that I want to change. So it's called size Y, and then dot, and then set, which means I'm going to set it a new value, 1.3. Let's say 1.4. Or you look at this like scatter points. So I created, let's say, no, this one. Where is scatter? This one. Whew. I created 1,000 points here. When I hover on it, it says parameter name is NPTS. So if I find that scatter point, which is this one, I can say that point parm, not point parm, NPTS was the name of that force total count number. Dot set to what? Let's say 40 or 35 or 20. Also, this attribute randomizer, like create a attribute randomizer, this one. Here I want to change that name to, instead of city, to P scale. I hover, that one is just basically name. So I say that P scale rand parm name is set to, be careful, this is a, oh sorry, here should be dot set. Name is a string, so PSK, so I put it in a string. And also, you remember me setting the mean value and max value. Mean is min x, just the first one. Max is max x, just the first one. So set those two as well. So I kind of like copy all of that. P scale, that one's gonna be min x is set to, let's say, half, 0.5 min, max x is set to 1.5. So it's between half and 1.5. If you want to set a multiple component, you just, so far we've been using parm. You can use like parm tuple. Let's say for the grid scale here, for the scale of grid scale, you see that I want to scale it. If I hover on x, it says SX, SY, SZ. Should I do that like 3 times here? No, you can just like after grid scale write grid scale, this time parm tuple, or which kind of like multiple. And I just use S, I don't say X, Y, Z. I just use the core attribute, and it's set to, so we need 2 parentheses here. So it's 1.2 maybe, 1 and 1.2. I don't want to scale it in Y direction. It doesn't make sense because it's just a grid. So, and also, if you remember about, let's apply what we've done. It works and it gives me the city. However, you see that it's that's like transferring. You remember that I have match floor for that one. I have copied the center and I paste it into the translate y. Actually, you can copy it from here, copy parameter and paste it here, paste relative value. If you, so you have, you can basically copy it from here. Is it from the block? Yes, block, not ty actually. I want to copy this one. Copy parameter. Oh, no. Copy relative, oops, not paste relative. Copy parameter x, and this one paste relative reference size y. Yeah, that was it. But it's just floating because it should be size 1 divided by 2. So that's the code. Actually, this is a technique that you can use sometimes. You just like, here you want to set an expression. You can grab that expression into your code. But I'm going to tell you how to set expression. So we're going to finish in 5 minutes, by the way. So sorry if it takes longer. So this match floor tool, you can just use this. Instead of set, you say set expression. So I just type match floor, where was it? There it is. I can say that match floor dot parm translates y is equal to set expression, and then you just like copy that expression from here to here, and you just see that it suddenly gives you this who parm, which you don't need it actually. You just need it's the object up to their expression divided by 2 basically. Oh, did I grab all of that? I'm gonna grab all of that and paste it here. Yeah, that's the right. And I'm closing it. I'm gonna see if it works, or if this one gives me an error. Line 31, which is basically the same. Okay, so this is, the reason is I didn't put it inside that. Okay, so see that this one has double quotation. Make sure that the quotation outside is different than the inside. If inside is single quotation, use the outside one, double quotation. Let me see if it works. Yes, it works now. So you see that they are landing on the surface now. So we are finished with our script. We just have to send our script to the shelf. How? You can just drag and drop. You know, you can drag all of that, drop it to the shelf, like that. However, oops, I'll show you a better way. So you just make a new tool and name it. Let's say city. So the name is actually a hidden name. The name that you see there, so the hidden name, I just like make this camel case name that I like. But the label is just the one that you see there, city builder. So for the name, you don't use spacebar for the, but for the label it's fine. you can paste that script here. Oh, not that one, but all of that one there. And you can now I apply. And also, how do you want to give it? How do you give it to your friend? This way. You see, it is saved to this address. You can save it to your desktop, or basically, I don't recommend that you save it to desktop. Save it to same address. Always, your toolbar is getting saved. Your custom toolbars is getting saved to this username, your username, document, Houdini, toolbar default. Instead of default, I call it City Builder. So, and I apply. This is what is generated on your hard drive. Toolbar. You see that City Builder is there. This is what you can pass it on to your friends. So they load it. They load it here, and so now if I delete it, every time I click on this City Builder, it generates a city. However, I forgot something before we finish for today, and that is that you have to, because every time that we click on this tool, everything in the object level gets deleted. It's because of this for loop. Just delete that, those two lines. That's it. Apply, accept, so delete. So from now on, when I click, this first one is generated. If I click again, the second one gets generated. It's very interesting that each one of them has a kind of a randomized pattern generated, different than the others, because it has a randomized attribute inside in it. Okay, so that was our first very basic Python scripting.